Hey guys, Troy from the Do-It-Yourself World Electronics. I am setting up another experiment based on the comments on the last video. I've got here the two batteries I was charging previously. I have separated them. Now what I've got is a common negative tied into the common negative here of the output of the Bedini motor. The positive is not tied up to anything but to the each voltmeter. This battery here is hooked up to this voltmeter at 2.12 volts. The second battery here is connected to this voltmeter at 1.17 volts. Okay, these were tied in together previously. Now don't forget, these were junk batteries that I have. They were at 0.07, I think it was, when I got them and took the caps off and refilled them with distilled water. Now I haven't had them running for very long. Being such a low voltage, it's convenient for showing extreme swings and charges. So they're very sensitive, whereas a newer battery wouldn't show any changes very fast. So that's why I like them for now. Plus, I hope to restore them eventually. Anyway, that one's fluctuating a lot. I have no idea why, but so there's the two battery voltages right now. Okay. Now, I'm about to connect I have two diodes here on the Bedini motor connected together. They're both tied into one crimp-on end connector to the collector of the transistor. So the transistor's here, and that aluminum plate is tied into the collector of the transistor, and the normal output goes into through these diodes to this bus bar, and then on out to the big batteries, which I'm going to leave in place, because if I perform these experiments with small batteries, I could fry my transistor. So I'm leaving those big boys in place. The experiment we're performing today is using two similar diodes connected to the collector of the transistor, and we're going to connect them, one diode to one battery, another diode to another battery. Then I'm going to experiment with the capacitor across one of the batteries, and we're going to watch the voltages and see what happens, see where they sit. Obviously this one's dropping as we speak, but anyway, we're going to watch these and see what happens when I leave one just on the Bedini charger and the other one with a capacitor across it. We'll monitor them with time and see if the capacitor is simply filtering out voltage spikes. Then we aren't going to see an increase in charge on that battery. We're just going to see the voltage change, but we should not see the voltage continue to rise any more or less than the other. They should continue to charge at the same rate, although the readout on the display is going to be higher with that voltage. I know I hope that makes sense. I hope it comes clear when I hook this up. So I'm going to put this on a tripod, or actually maybe I won't. It's easier to hold it and show you the meters. I'm going to connect the outputs and we'll be back in a minute. One thing I did do is I hooked up one of my new meters. I took off the amp meter I was using that went from 0 to 5 amps, and I put on that milliamp meter. Now it started out at 100 milliamps and it's rising as the speed of the motor goes up, which makes me nervous. I don't want to damage this meter, so I'm going to turn the resistance up some, which should drop the current considerably. Yes, it drops that current. So I can keep that under 150 milliamps. Now it's starting to rise as that motor increases in speed again. I can keep that around 100 milliamps, I think. So I'll keep an eye on that as I perform these experiments, but now I have a more accurate meter. These have a plus or minus 2.5% accuracy rate, which is not good at all when you're looking at 0 to 5 amps. When you're looking at 0 to 150 milliamps, you got a lot more accuracy on here. So I'll keep an eye on that. Anyway, I find that interesting. Oh, there, it's reaching its peak speed. And now the current intake actually starts to fluctuate It dropped a little. Yeah, it's acting funny. These are... Nope, and it jumped up some. These are really interesting machines. It's very hard to correctly read them with an actual meter, because it is pulsed voltage. So I'll turn that resistance down or up a little bit more. See if I still got, make sure it's still got some energy going through. Alright, I'll keep an eye on that. I have these two hooked up to the outputs. 7.6 volts, 7.0 volts. Okay. Nothing different right now between the two batteries. So this is reading this battery, okay? This output is reading this battery, and this meter is reading this battery. Right now they're pretty close. 7.0, 7.6, slowly rising. Alright, I'm going to let it run like that for a couple minutes, just to see if the voltage comes up on its own. Alright, that one is definitely rising, the one in the back. No, this one is slowly come up. Well, this meter is more accurate, but it also means it's more awkward to follow. You can see the voltage is really jumping up and down in there. Anyway, I wonder. This has got a frequency measurement as well. I'm going to look that up and see if I can use that to my benefit at one point on this experiment. Anyway, we'll let that go for a few minutes and then come back to them in a little bit. Okay, about 45 minutes has passed. 7.63, 7.64, 7.4 something or other. It fluctuates. I don't know if I mentioned, but I swapped out the meter because the other one was fluctuating so much. It has a finer precision and I didn't like it, so I put this meter on. It is fluctuating, but not as bad, and that one's pretty stable. So this one is this battery here. This one is showing this battery here. Now I'm about to put the capacitor across. Let's see. Well, this one is fluctuating like mad, so I'm going to leave him alone. Put it on this guy here. So minus to minus, and then the plus. Where is he? To the plus. Alright, now when I connect this, you watch that voltage jump. Boom. 12.3. Alright. Did that one drop? Wait a minute. Let me try something here. 7.2. What was that a minute ago? I'll have to check the video to see. 7.2. And it's holding at 7.2. I'll have to check the video and see if that changed. But this goes up. No, it's still going up to 0.25, 0.26. That was 12.31. So let us see what happens here. We'll let some more time pass and we'll come back out. This one seems to be sitting stable for now. This one's fluctuating, trying to go up to 7.26. So it's taking charge. 12.31. I think I'm going to write these down. Alright, we'll be back in a little while and see if this is indeed still charging, and if it's still charging at roughly the same rate as this one. So, oops, dropped to 2.30 a minute ago and I'm back. Alright, we'll be back in a while and see what happens here. Alright, I have this same smart pocket oscilloscope. It's not very accurate, but it shows me the voltage spikes. It's a weird pattern. It's a very weird pattern. Looks like 4 peaks and a low. I'm not quite sure why that is. Now again, this is not really accurate, so it's not necessarily the real deal what we're seeing here on here. But that's this first battery, which is sitting at 7.17. Now when I put the scope on, the voltage dropped some. So the Bedini motor is very sensitive. It doesn't like meters, I know, and it doesn't like all this junk. So I know that anything you add on to the back end is going to change the charging rate, so it's awkward. Anyway, that's the pattern we got on the first battery. Now I'm going to move it to the second battery. I'm just going to remove this clip and put it on to the positive of the second battery and see what we get for a pattern. The capacitor has smoothed out the spikes. Yes. One thing about this is it, there's 0.1. Yeah, it's awkward to, I need more precision on this thing is the only thing. I really need to get more precision. I can't turn down the voltage any further because it goes off the screen, the sensitivity. Let me see if I can. There was a spike visible. Yeah, it's a problem. I've got 1 volt and 0.1 volt, and that's the only range I have in here, so it's nearly impossible with this little oscilloscope to get a good reading. When I go to 0.1, it goes, I see a spike and it goes off the screen, but I can't quite get that on there. So it's impossible with this oscilloscope to widen that out and see what's really going on. And if I remove the probe, there's not much difference. Yeah, now it's off the screen again. So I don't know where it is now. It's not the best. Oh, I'm on AC, that's why. Alright, now it should bring it back. Oh, anyway, this is not the best example of a scope to use. But the capacitor is filtering out the spikes. Now I can't get the line back on the screen. So we'll go back on the first battery. Let me pause the camera. Alright, the battery without the capacitor. And I definitely can't bring that into the screen better. Oh, there it's better. Now I got it on there. Let me see if I can slide it down some more. Well, there's a better view of the pattern. There's a 1 millisecond setting. Let me see if I can lock that on the screen. Alright, well that's as good as I can get it. It's not showing me the frequency or cycles, duty cycle. Probably because there's a long DC pause in there. But it's an interesting waveform on there. Now the other one, like I said, it is smoothed out by the capacitor. Okay, we'll leave that on there for a while. See what happens. Now my experience is this one's going to come down a little ways because when I first connected the capacitor, it jumped up and spiked high in voltage and later settled down to a different voltage somewhere in between. So this isn't going to prove much. It's hard to prove anything because the voltage is going to come down for some odd reason, which makes me wonder why that occurs. But we'll come back in a while and then you guys can tell me what you think. Half hour has passed. Now, I can't say I can draw anything conclusive about this. This battery's voltage is going up slowly. Unfortunately, with the capacitor on there, it's going to take a long time for that to level off, flatten out, and then start to show a charge again. So I cannot conclude anything right now with this at all. It doesn't prove anything to me one way or another. I do have an experiment I want to try though, a couple of them. I'm going to put the LED lights back in, or put them in along with one of these batteries and see what happens. Now I've tried it on the primary output with pretty interesting results. I'm going to try it on one of these little guys. Well, the lights don't come on, but the voltage starts rising rapidly. Sorry, the blinking light in this camera is annoying. That's odd. Nothing happening here, but definitely the voltage is coming up much faster now. Way faster. Now I can't explain that away. Can an LED act as a filter? We've got, essentially consider this as all as one LED. So the energy has to pass through an LED to get to the battery. So, but there's no glowing or anything, no light. But the voltage is going up way faster. So what's going on here? That's interesting. I think I'm going to leave that for a while. We're down to 90 milliamps on the input. And this is, by the way, a battery that was junk. It was at 0.5 or 0.7 volts when I was in New York. This one and that one I've been restoring on the Bedini motor and cycling through, using them and charging them and discharging them. So that's powering the motor right now. A battery that was deader than dead has now been running this for an hour and a half or so, and can continue to do so for quite a while. And here we see real work being done. So that's pretty cool. Well guys, the system's been running for over 24 hours. This one is showing 14.7 volts, 15, I don't know, it's fluctuating a lot. This is the one with no capacitor. The one with a capacitor is showing 12.26. It hasn't changed in 24 hours. No, this is definitely what you would call a surface charge. There's not much on there at all. So I'm going to shut the machine down and see where these voltages go. Funny, the one with the highest voltage is actually showing the lowest voltage. Let me take the capacitor off, because that's probably showing. Let me see here. I can get that off. That's in there good. No, it's the battery voltage, 7.57. Interesting. The one that had the capacitor has the highest charge at rest. Weird. And the other one has dropped a lot. Alright, I'm going to let these rest overnight, and we'll come back in the morning and see where they stand. But the one with the capacitor, now I've removed the capacitor. The one that had the capacitor has the highest charge at this time. So, and the other one is dropping still. Well, we'll come back tomorrow and see what happens here. Hi guys. So after resting a longer period, the battery that had the capacitor on it has a higher resting voltage than the battery that did not have a capacitor on it. Which shows me there must have been a greater charge on the battery that had the capacitor. I mean, the numbers are showing it right here. This is after resting all night. Everything else was shut off. The meters were off, everything was off. So there is definitely a greater charge when using the capacitor. So although the capacitor may be acting as a filter, it's definitely charging battery more powerfully than not using it. Now, I might just reverse these and put the capacitor on this one and run it for the rest of the day, and then leave this one without and see what happens at the end of the day. But that'll be another video. Talk to you guys later. Troy from the Do-It-Yourself World Electronics. Another experiment with the Bedini motor. Always exploring and learning and seeing what we can do with this and how we can improve the output.